Computers need IP addresses to communicate with each other over the network. How do you assign IP address to your computers? You can sign into every single computer and assign an IP address statically. And then you have to move on to the next computer, next, and so on. Is it a sustainable solution? If you have like 5 or 10 computers, yes, maybe we can handle that. We can keep track of the IP addresses of each computer. But imagine an organization from even a medium to large size organization with hundreds or thousands and thousands of computers. Assigning IP address and managing the IP addresses manually is not practical. There should be a service for that. The service is called DHCP. DHCP or Dynamic Host Configuration Protocol. DHCP allows you to assign IP addresses automatically to your users and also allows you to send other options as well. Options like setting the DNS server, setting the default gateway, and many more. You can set your time server. There are so many options that you can send along with your IP addresses to your clients. My name is Ali, and in this series of videos, I'm going to show you how to create a DHCP server, how to configure a DHCP server, how to create redundancy, and many more. The videos will start from the very basics of how does a DHCP work. The difficulty of each video will gradually increase. We start with the basics of how DHCP works, then we install the DHCP server, we move on to configuring a DHCP server, and following with advanced videos of advanced configuration. In general, on the DHCP servers, you create pools of IP addresses. From those pools, you assign IP addresses to the clients based on the configuration and the requirements of your network. If you have multiple networks, you will learn how to design your DHCP infrastructure in different networks, using one server or using multiple servers. How do you provide redundancy? How do you provide failover to your DHCP server? Join me on these videos to master the DHCP. Let's start. The process of leasing an IP address from a DHCP server to a client is a 4-step process. On step number 1, the client sends out a request to find the DHCP server. It literally asks, who is DHCP server on this network? On step number 2, the DHCP server responds to the client by saying, I am the DHCP server and I can give you this IP. Step number 3, the client responds back and says, hey, that sounds like a good idea. I would like to have that IP address by sending a request. And step number 4, DHCP comes back and responds with a yes IP address and acknowledges that the DHCP can issue the IP address to the client. There are 4 packets that being transferred in these 4 steps. On step 1, the client sent a discovery packet to find the DHCP. On step number 2, the DHCP server sends an offer to introduce himself and introduce a potential IP. Step number 3, the client requests the IP address, and step number 4, server acknowledge it. Now let's have a more technical look at the process. Client sends a DHCP discover, DHCP servers respond back with the DHCP offer, client accept the offer and respond with DHCP request, and finally DHCP server accept the offer by DHCP ACK. And if for any reason DHCP cannot lease the previously offered IP address, we'll send out a NACK or not acknowledge package. The 4 steps in generating an IP address lease in a DHCP are DORA or DORA. First, the DHCP client sends a broadcast package called DHCP Discover. Only the computers that have the DHCP server role installed on them will respond to this package. Or if you have any routers on your network that have the DHCP service installed, they will respond as well. A DHCP server responds back with a packet called DHCP Offer. On the first package, client is looking for a DHCP server. Now the responding computers will respond with an offer. This packet contains a potential IP address for the client. If you have multiple DHCP servers in your network, then they will all respond back with a DHCP offer. The client will receive multiple offers, and the client can accept the first offer that it receives. Once the client accepts the offer, then it will send back a DHCP request packet that contains the server identifier from the DHCP server that the client is accepting the offer from. Once the client sends out the DHCP request packet, all the servers or all the DHCP servers in your network will receive the request. Those servers that the client has not accepted their offer take this message as a notification that the client has declined that specific server's offer. Then the chosen server stores the IP address information in its own database and responds back to the client with a DHCP acknowledge message, a DHCP ACK message. If for any reason DHCP server cannot provide the address that was initially offered to the client with the DHCP offer package, then the server needs to send a package called DHCP NACK or not acknowledged. We know that the lease period of each IP address is specific. As an example, clients lease the IP address from the DHCP, and by default the time is 7 days. How do the clients renew their IP address? The process of renewing the IP address is shorter than requesting a new IP address. This is a two-step process. When the client reaches 50% of the lease period, it will send a request to the same DHCP server that initially leased the IP address and request a renew, because the client knows the exact DHCP server who initially gave him or her the IP address. The client sends a unicast request directly to the server. The server then responds and acknowledges the request. With that, at 50% time left in the lease period, the client has successfully renewed the IP lease. Let's take a more technical look at the steps. Clients lease the IP addresses from the DHCP server. They cannot hold on to the same IP address forever. If we did not have a time period for the IP lease, then after a short while the DHCPs would be running out of IP addresses and the new clients would not be able to get the IP addresses. In the next videos, we will learn how to define these time periods. By default, when you set up your DHCP server, when they lease an IP address to a DHCP client, they allow the client to keep the IP address for 7 days. That's the lease period. When the DHCP lease reaches 50% of the lease time, the client automatically attempts to renew the lease. This process occurs in the background. User will not be notified. It is possible for a computer to keep the same IP address leased from the same DHCP server for a long time. This is because the computer renews the lease multiple times. The client can reach out to the DHCP server, request a renew on the same existing IP address, and extend the lease. To attempt to renew the IP address lease, the client sends another request to the DHCP server. This time, instead of sending a broadcast message, client will send a unicast DHCP request message directly to the server who issued the IP address. The server that originally leased the IP address sends a DHCP acknowledge message back to the client and allows the client to renew the IP. This message contains any new parameters that might have been changed since the original lease was created. In future videos, we will see that DHCP can also send options along with the IP as well. So if any of these options have been changed from the day that the client leased the IP address with the new request, the client will receive all those changes. Something that we can consider right now is that these packets are not being broadcasted. They are not being sent over to the entire network, because at this point of time, the client knows the IP address of the DHCP server who issued the IP address for the first time. For that reason, the client can use a unicast communication method and send the request directly to the DHCP server. If at the 50% time of the lease, the client cannot reach the DHCP server, maybe the DHCP server is down or the client is not in the same network, network, the client will wait until 87.5% of the lease time. At that point in time, the client will send a broadcast request. This time, client sends the request to all available DHCP servers on the network. It sends the request to the entire network, hoping to hear from any available DHCP server. But the only difference that this broadcast has is that this broadcast request is for a renewal, not a new lease. We know that some clients might be moved when they're turned off. For example, laptops. If you have a laptop, you turn it off in this office today and you turn it on in another network the other day. For that reason, the client computers also attempt to renew their IP address at the startup process, or when the computer detects a network change. If renewal is successful, the lease period will reset, and the client can keep the same IP address for another 7 days. So with that approach, even if you set the lease expiry to 7 days, every 3 days the client reach out to the server and renew the same IP address for another 7 days. Now that you have learned how does DHCP work, join me on the next video to create our first DHCP server. See you on the next video. If you enjoyed this video, please give it a thumbs up and consider subscribing to the channel for more videos like this. Make sure to hit the bell icon to be notified when the new content is released. Also, leave a comment in the comment section down below and let me know what other subjects would you like to learn. Thank you for watching, and I hope to see you on the next video.